Hello everybody. So first of all, thank you for having us. Thank you so much, and thank you for being here. My name is Tina Schlingmann. I work as a market engagement officer at the EMEA at EOS, and today is the idea that I introduce you a bit to our metal and polymer portfolio and show you a bit our systems, but then also give you an overview and first idea of the applications, and then I hand over to my colleagues. So EOS, thanks B-roll, we were already a little bit introduced, but that you get a feeling. We are the technology market leader in the 3D printing or additive manufacturing industry, and we have a footprint of 5,000 systems in the market, and it's a family-owned company existing for 35 years. Here you see a first overview, and you have already seen some nice pictures of our systems. So what is interesting to mention that we have polymer and metal systems. And my idea is to split my presentation in two parts, where first of all I start with our polymer systems, and then in the second part we deep dive a bit into our metal systems. So let's start with the polymer deep dive. I decided not to start with a system because actually they look a bit boring, all the same white systems. So I decided to start with an application which is hopefully a bit interesting for you, which is drones. And coming from that application, I decided to start with a picture where you might ask, what has that to do with additive manufacturing? So here you see a conventional way of blood transporting. So when you have a blood infusion and you want to bring it from one hospital to another, then the typical way, at least in Germany, would be by car. And how can the future look like? So here you see me on a conference, and I was discussing with the first European airline for drones, so the Turkish airline or the Lufthansa for drones. And that shows us that this application and this business and industry is growing and coming. And this is one application we are focusing on, and where 3D printing or additive manufacturing can really make a difference when it comes to the technology, because it gives us the possibility to react really fast and have really short development cycles and really react on the market and develop small lots of drones in this case. So additive manufacturing allows you to respond to market changes quickly and constantly innovative. And here you give or you see an example, because when we talk about drones, then we talk about lightweight, right? Because what is interesting is that we bring the weight on that what the drone is carrying and not on the drone itself. So that's why it's really important to find a technology where we are able to produce things in lightweight design, and this is an example when it comes to the drone. And also it's important to mention that it's not only about the system we're talking, but it's always about a triangle. So it's always about the material, the system, and the process. And also my colleague later, I know he will also dive deeper into this, but it's important that we keep this in mind. So coming to our systems, here you got a rough overview. I honestly do not expect that you can read through all the details, but what I want to share, or the main message, is that we have different sizes of systems. So the smallest one is the Formiga P110, having a building chamber of 200, 250, 330 micrometers. And then we have the sister with a fine detail resolution when you really want to have a super good surface quality. And then the latest system we launched last year at the Formex, which is the world's biggest fair in 3D printing each year in Frankfurt, is the P3 Next. And Then we have bigger systems like P500 and P770, which is our biggest one, coming with 2 lasers and having a building platform of 700 millimeters, so quite big, just to give you a rough overview. But from our perspective, we prefer to start from the application and then bring the solution to you. Going a bit deeper in the P3 Next. So before we were launching the P3 Next in November last year, we had the P396, and by this new launch, we reduced our TCO by 30%. And then also we worked a lot on the getting faster in the recoating time of the process. We worked on the innovation when it comes to the heaters, so we have a better temperature on the surface and the better quality, and also the exposure we were shortening. So that's why we reduced in total the layer time, and then we could speed up the whole process. And moreover, and here you see the blue is the blue ring is the printing time, the building time, and on the left-hand side you see the new system, and on the right-hand side the former system. And you see that the blue ring is way smaller or shorter when it comes to the old system, since we had a big block of cool down time. So there was in the old system a long time where we were just waiting, and nobody in production is interested in waiting. So what have we done? This new system is coming with a cool down station, which brings us to the point that we can remove really fast the printed parts, even if they are hot, and bring them to the cool down station and then start immediately a new job. And then also, and here Sean Kelly, my colleague, will talk later a bit more on this, but we also launched two new polymers. And when it comes to polymers, we are always talking about the refresh rate, about the reuse material, and with that we have a reuse of 70% with the material PA. It's a PA12, so with US it's called PA 2020-20. And moreover, we launched another material, which is from our American sister ALM. It's a PA 950 with high definition. It's a black material, as you can see. And there we have a reuse of 80%, which is quite high, and that really it's a really innovative step in this branch. Metal deep dive, the second part. So let's have a little look in our metal portfolio. I decided to start with an M290. And I don't know how long you are in the market, but for me it's now 12 years. And when we talk about the EOS M290, then often the people say, ooh, they're so long, this M290. And now we are joking like, oh, but it's boring, reliable. So in the end, this is our like basic platform or starting platform. And we have more than 2,000 M290s worldwide in the field, which is quite a big number, knowing that we have 5,000 systems in total. Then the former systems were called M270 and M280, and there are still customers producing with the former systems, so 72% of the customers. And then also we have many materials, more than 28 materials on that system. So it's a really nice starting point, I would say. And that's the reason why we decided to develop a whole family around this system. So starting with the M290 single on the left-hand side. Oh no, this is not working. Then the system comes also with 2 lasers. It's the M290 dual, but then you can also decide, and it really depends on the application you want to print, on the process, on the material, that you can have different lasers. So 400 watt laser, but also 1 kilowatt laser, you can have 2 lasers, and so on and so forth. And this is what we are doing with our sister AMCM. So we're always joking, AMCM is the AMG of EOS. So what AMG for Mercedes is our AMCM. So when you want to have a special solution for a special application, then we can build it customized with AMCM, and AMCM means additive manufacturing customized machines. Smart fusion. So it's not always about, or it is about innovation, but it's not always about a new system, new system, new system. It's also about the software. And this is something I want to show you where we start, for example, with our M290 system. But then we have the chance, only by a software solution, that you can see on the right picture, the same part with a lot of support structures. And on the left picture, there are just a few support structures. And we didn't remove the support structures. They were just not printed because of a new software. So first of all, why do we need support structures? When we talk about metal systems, then we need the support structures that the heat that you can remove the heat from the builded part. But also that the part is not removing from the plate, basically. And now with that software, Smart Fusion, we found a way that we have an OT, so OT camera, which is measuring the amount of the energy. And then, for example, on the one spot there, it's very, very red, so very high amount of energy. And then in the next layer, the laser is reacting. So first we have the measurement, and then by tomography, and then the laser is reacting on that. This means that we have, when you compare the two pictures on the right, then on the right-hand side, you would see a picture how the heat would be distributed without this Smart Fusion. And on the left-hand side, you see it's completely blue, so you have completely smooth and very equal distribution of the heat only by this software. And here's just an example of impeller, just an application part, helps us to reduce the build time in this part by 35%, the material consumption by 20%, and we reduce the post-processing costs by 85%. This goes not for every part, but only for this one. It really depends on the geometry of the part. Next step, we want to go bigger, so we do not have only the M290, but we have also like bigger siblings. And this is one of us, it's the M400-4. -4 always means with printing with 4 lasers, and it comes with a dual setup station. So the white box on the right is for changing jobs, so you can print 2 jobs in a row, and this also brings us to increase in productivity, since you're also, as similar to the P3 Next, you don't have to wait until the whole job is cooled down, but you can also switch it in the dual setup station, and then you increase in productivity, and this is what is interesting. And also here, just to give you more ideas how it can look like, the whole setup can look like. So here you have a lot of M4s connected in a whole big factory. Based on the M4, we have now, and I was already mentioning our AMG, the AMCM, we have the M4K. So this is especially, I would say, also for defense industry really interesting. So we have a lot of defense customers here, and at the moment 42 installed systems in the market. And here you see like Centavia and Lockheed Martin and Oerlikon, some example customers having that system. So big portion is defense, 30% of the market, the other 35% is space, and so that's the main information, I would say. Talking about that system, just to give you an idea, before I was mentioning 700 millimeters, now we can talk in metal about 1 meter high parts, and we talk about 4 1 kilowatt laser. This is a lot of energy. This is how the building platform looks like, and you have these 4 lasers, and you have also an area of an overlap. And here you have a whole setup. So this machine comes with a sieving station on the right, But then you can also close the whole powder loop, so you have the sieving and then the build process, and then the unsieved material is going back in the loop, and you can close the whole loop. Because when you, for instance, take the M290, then you do not have this powder loop automatically. You need a special periphery, but here you see a solution where we close the whole loop with the powder. And as I was mentioning, we are building customized systems, so also there we can get bigger and higher and having different and more lasers. So this is an M8K. So before we had M4K, now we have M8K. Customer is Ariane behind this one. And here we have 8 lasers, and the part, you can get a feeling how big that part is, but it's already quite huge. Talking a bit about the timeline of this project, the first delivery is planned for the beginning of 2026. And last but not least, now I was talking about different materials, about different sizes, and I was already mentioning that you can also change the kind of the laser. You can change the laser power and the profile of the laser. And this is our flex systems. So here you see already different beam shapes, we call it. And this goes now a bit deeper. So what do we mean by that? The normal profile of a laser is a Gaussian profile. And with beam shaping, we have the chance to shape this profile to any form you want, more or less. And one form which is very common is the donut beam. So the normal Gaussian profile you see here, and then we developed a mode with a donut beam, and we also can build a thicker layer thickness. And this, I very much like this part, because here you can see one part built with 3 different parameters or 3 different laser shapes in the same time. And this shows really plastic that you can build the part in the back in the same time like the low part, but that's the advantage of a different laser. And with that, I come to an end. Everyone who wants to meet us at Formnext, we are there. It's in 2 weeks in Frankfurt, and you can be curious because we're launching a new system. I'm not allowed to talk more about it, but as it's only 2 weeks, stay curious and visit us. Thanks for being here and having me.